thank you so much for the kind introduction. I'm Nico Williams. I work at 2 Sigma. I work at a tech risk and security team. I work on all sorts of authentication technologies like Kerberos, PKI, and OAuth, and credential orchestration systems. I also work on a bespoke directory service and a bespoke authorization system, among many, many other things. But those are the salient ones. And about 2 years ago, maybe a little less, I convinced someone at the OpenSSL team to build a fairly complex piece of code, RCU, for making threaded code in Heimdal, in OpenSSL fast, right? And so I feel suddenly very influential. And so I thought, well, maybe I can make them do more complex stuff, right? And then I don't have to do it, and that's even better. OpenSSL, like many other things that use ASN.1, really need a compiler, and it doesn't have one. Now, Peter Gutman says I should stop here and just get off the stage and just say, that's it, that's the whole presentation. But I actually want to do a little bit more than that, right? So, I don't really mean to make a tutorial here about what ASN.1 is. By the way, how many people here know what ASN.1 is? And how many people don't? All right, so great. I'm going to skip all this because there's only one. But actually, I do want maybe people who are new to OpenSSL or to TLS and ASN.1 in general to just know a little bit because, well, maybe I can get one of you guys to do this, right? So it's an IDL, an interface definition language, and a bunch of encoding rules, and this is the one that's really used by PKI and a lot of things at IETF. But it also does just a lot of other things, right? So including XML and JSON and whatever. You can add your own if you want. And briefly, this is what a certificate looks like in ASN.1. The sequence really means struct. It's a sequence of fields, right? They come in sequence, just like in a struct. So it's a sequence. And this is what a TBS certificate looks like. And you see there's a bunch more crap, like there's those small integers in square brackets. Those are called tags. And then there's things like some fields can be defaulted, meaning they're absent in the encoding if they have the right default value. And same thing with optional, right? Like they can be left out of the wire. But anyways, this is not interesting to most of you, so I'm going to skip. And it's everywhere. It's in Kerberos. It's in PKIX. It's in lots of various financial and telecommunication protocols. And some of you might be like, why not protocol buffers, right? It's 2025. And, well, I'm not going to start on that because I'll waste my entire time on telling you how bad protocol buffers is. So I'm going to skip. Anyways, ASN.1, these are the relevant ITUT specifications, X680 and X690 and related ones. OpenSSL, MIT Kerberos, and a bunch of other things tend to hand code, their codecs. And this kind of sucks, right? There's been lots of security vulnerabilities. People make mistakes when writing these, when transcribing ASN.1 modules to whatever it is that they're using, right? And you're not going to have AI review AI-generated code, and you're not going to review it yourself either because it's very long and boring and repetitive. And so you really want real tooling so you avoid the security problems and use your labor more efficiently and iterate faster, right? That's why Heimdal, which is a Kerberos and PKI implementation, has an ASN.1 compiler, because they wanted to be able to immediately implement anything that's in any new internet drafts, any new RFCs. It should be easy to do that. And it is if you have ASN.1 tooling, and it's not if you don't. Well, the reason that a lot of things hand code their codecs, there are several reasons. One of them is that long ago, the specs weren't really available. They were not cheap. Now they're free for E versions. And there was no tooling. And and also, tooling. You'll find interesting impedance mismatches with what you want for what it is you're implementing and what the tooling provides, right? So people tend to just wing their own. Anyways, but we do want some tooling, and it has to produce code that OpenSSL can use license-wise, and so it has to be free and open source as well. So that only leaves about 3 options, 4 if you want to write your own. And I don't know, maybe if you write your own, you can keep the machinery that you already have, and you just generate all the C code files that use various macros to do everything. So maybe you can keep the impedance mismatches to a minimum. And one of the things you're going to need, of course, if you're going to do this, is you're going to need pretty good code gen controls in your compiler. And I think this is going to drive you to building your own. But anyways, you're going to need at least the base ASN.1 and at least DER. Probably don't need all sorts of other stuff. You're really going to want something I'm going to show you in a minute that's really cool, which is, you might decode a certificate, but you want to keep the encoded TBS certificate around so that you don't have to re-encode later when you want to validate a signature. But then there's this more modern ASN.1, right? So I showed you X680, but there's a bunch of other X681, X682, and X.683. And these allow you to formally specify a bunch of things that otherwise you'd have to write down in English. And so that's all the things like certificate and CSR extensions and other things like that. Subject alternative other names. Well, this with syntax thing I'm going to show you in a minute. So here's certificate in RFC 5280, and then the same thing with the modern way. And since all the PKIX stuff tend to use the same pattern, it's possible to essentially have something like a macro where this signed thing is defined in these RFCs, 5911 and 5912. And so it's much nicer in a way. And here's what a TBS certificate looks like in 5912. So you'll notice that the signature now has this extra stuff in curly braces. These are parameters. And you'll also notice, well, some of the stuff is running off the page. I'm sorry. I thought I checked. But anyways, this tells you that these were extensions added in version 2. And ideally, I would be showing you that the certificate extensions also have a parameter. In this particular case, it's called cert extensions. Well, we'll show you in a minute. And what's an extension? An extension is a typed whole, which is basically an octet string. It's a blob of stuff, which represents some value of some type, which is indicated by the object identifier extend_id. And so normally, if you are decoding a certificate and then you want to look at the extensions, well, you'll have an array of blobs, and you have to go, well, which ones am I interested in? If I'm interested in subject alternative names, I'll look for the one that has the OID for subject alternative names, and then I'll decode that extend value and so on. So that means you write a whole bunch of code, first to invoke the codec for certificate, and then later to invoke the codec for the extensions you actually care about. And that sucks. That's a lot of manual code that the compiler can write for you. So one of the things you can do is fully decode, like one call to the codec can fully decode everything in a certificate. Everything that is a typed whole like this, you can decode it for you all at once. Now that might not be a good idea if it's very big and there's lots of stuff and you're only interested in 1% of it. But for certificates, this is pretty cool. So in Heimdal, this is what an extension looks like. So first we have the extend_id, which you can see is a Heim OID type. OpenSSL, of course, would use something else, right? So this is where code gen controls would be nice. The Boolean critical becomes an int. You might want bool or char or whatever. The extant value is an octet string, and then we have this additional thing, which is a struct. It's a discriminated union essentially, and so you get you'll get the first choice if the extant ID is not known to the compiler. That is, it wasn't listed in the module's cert extensions object set. I probably should explain what an object set, and I will do that in a minute. But otherwise, if it does understand it, then it'll actually decode it, and you'll have, for example, authority info access is the first, lexically the first extension in the cert extension set. So you'll get one of those, and subject alternative name, etc. So I'm not showing all of that because it won't fit in the slide. So here's a little bit of an example. Here's a certificate. I'm decoding it. I'm printing it with ASN.1 print, which is Heimdal's little tool. Basically, it has all the types of all the modules in the source tree compiled in, and you can tell it, I want to print this as a certificate. You can try printing it as something else, but you can say certificate. And I'm piping it to JQ, and here you have a thing. So the stuff with an underscore prefix is extra, added by Heimdal otherwise. And the underscore save, for example, is that's the TBS certificate as it was encoded originally. That's here shown in hex. And then you have like version, serial number, etc. Yeah. And here's, let's look at an extension. So here I'm looking at a certificate, and I'm using JQ to look at all the extensions, but only the ones that have subject alt name in there. And this one has, well, one of those. And notice, by the way, that the OID is printed with a nice name. That's the symbolic name in the ASN.1 module in the tree. And you'll also see that this name is a RFC822 name. That's an email address, and the value is shown. And yeah, but it does this for everything in one go. So that's really nice. So yeah, so maybe we can, make a compiler or Heimdal's compiler or something output something that already works for OpenSSL right out of the box. I don't know. Heimdal's ASN.1 compile command actually can output a JSON representation of your module, and you can use this to drive code gen. My friend Luke Howard actually did this for Swift. So he took this compiler and he used the ASN.1, the JSON output of the representation of a JSON representation of an ASN.1 module, and he used it to generate Swift types and code. So one could do the same thing. I mean, heck, one could even use JQ to drive the code gen. This is the command line option that says, hey, I'm going to want TBS certificate to be preserved in its original encoding so I can validate signatures without having to re-encode. And that field is the field that will have that in TBS certificate. Right, so I already explained why you would need this. One thing I wanted to point out is DER would never have been needed if this had been, this had existed on day 0 of ASN.1. You can also do things, this is really cool, you can decorate the types that it generates. This is useful for if you want to do intrusive data structures, which I hear OpenSSL does a lot of, so here you go. You can decorate with other ASN.1 types, you can decorate with bespoke C types, whatever you want. These will not be encoded on the wire, of course, right? So if you want to decorate your certificates with stack of whatever, well, this will do it. So ASN.1C and SNAC don't support -- preserved binary. At least I couldn't find that they do, but I only did a cursory look. And only Heimdal's and ASN.1C compilers support some of the features in RFC 5911 and 5912. And if you wanted to build your own, well, that's tricky. ASN.1 is tricky because it's kind of ambiguous. It's context dependent. So some things you basically have to parse the whole thing to then decide what kinds of things you parsed. That's kind of annoying. That means that using Bison, Yak, these things is hard, it's tricky. And with syntax is probably going to be beyond anything you can use, any Yak or Bison parsers. But hey, you know, maybe you can have an LLM help you generate an ASN.1 compiler. I mean, it's not that bad. I've actually used some LLMs and gotten good code out of them. Now, I tend to rewrite the code anyways, but you know, I find myself at the start of a project not knowing what to start on, right? It's like you're climbing a big mountain and, you know, it's like, so much work. I don't want to do it. But if the LLM does some of it for me, then maybe I can get started in sprinting. And so, I don't know, maybe that'll work for you. Anyways, code gen should be easy. Anyways, I have this idea that I could write a JQ-based ASN.1 parser. JQ is, you know, has pervasive backtracking, and so essentially a left recursive parser with backtracking can do it. So I don't know, I have approval to do this on my spare time, and I might just do it for the fun of it. But I have a billion other things to do. Anyways, a little bit about code gen controls. In-band controls are tricky because you don't, that means modifying the modules, and you don't really want to do that. Heimdal lets you do things like put size constraints on integers, and then it will pick the smallest C int type that fits that, right? So that's a pretty simple kind of in-band control. The other ones I showed you some of them, like -- preserve binary. And you could do lots of out-of-band controls like that. Heimdal's compiler actually lets you put all those command line options in a separate file. So you don't have to be always, you know, putting them in the command line. You can tell it to read them from a file. So essentially that becomes a file that has your controls, your code gen controls. Whatever. And then a couple of things about Heimdal's compiler. It has two backends, one that generates a function for every type, the C function for every type, actually several. And it also has something that it calls a template compiler. It's kind of a byte-coded thing. And the templates are smaller. They use much less space, about 59% for PKIX. And what that means is that in today's systems where cache pressure matters, right? Especially your iCache, these can actually go faster. Well, that's the theory anyways. I've not measured it because for PKIX and Kerberos, it doesn't matter. You're doing crypto. So your codec performance is not going to matter that much. And the template kind of looks like this. It's arrays of these things. The first field encodes tag and type information, and the second field encodes offsets into C structs or other things. And then the last one points to either a subtemplate or other relevant information. And yeah, I mean, you know, the first field can encode 21 bits of tag numbers, which is overkill. This is really not very well optimized for sizes. You could optimize it even more, but you'll have more branches, so I don't know. But anyways, these are really smaller, 59% smaller for PKIX. So what should OpenSSL do? Well, you could use Heimdal's compiler. If it's an external dependency, you can just use it. And, well, you could always commit its outputs if you don't really want to have people have to install Heimdal. By the way, Heimdal depends on OpenSSL, so that's kind of a circular dependency. But at least the ASN.1 compiler doesn't, so it could really be removed from Heimdal and made a separate thing. So you could either use it directly, have it code gen for you, or just indirectly use its JSON output to drive code gen yourselves. You could write your own tooling. You could mimic Heimdal's to some degree. I think it's probably a good idea, except maybe not using Bison. Maybe you want to write your own parser generator for that. You could fork Heimdal's. That's a little tricky, right? So I'm told that everything has to have copyright assignment in OpenSSL. So that's probably not an option. There's license issues, right? Maybe Heimdal could donate, do the copyright assignment. There's only 21 authors that have ever touched the ASN.1 code. Fewer when you exclude trivial contributions. So you can, and I think we're all alive, so you can probably contact all of us, and we might do it. I don't know. And yeah, there's one more option, which is you could use Heimdal's template generation and then just write your own interpreters, right? Because the template comes with interpreters. And you could write your own, and then thus you do your own code gen for types, but use Heimdal to do the template code gen, and then finally you have your own interpreters. So there's a bunch of options you can do. Right. I meant to add a slide, and I sent one. I had forgotten to have a link to Heimdal, but it's Heimdal/Heimdal, all lowercase, in GitHub. Anyways, all right. So yeah, these are the options. I hope that you'll build your own, right? And I hope that you will take inspiration from Heimdal's. But also, I'd be happy if you used Heimdal's. Perhaps the JSON output to drive code gen approach is a good idea for OpenSSL. I don't know. You'll probably want to keep the machinery you already have to some degree, so that it's a pretty easy lift, right? Just drop in the compiler and everything should just work without having to change all the places where you invoke your codecs, right? That would probably be a good idea. Otherwise, it's going to be a lot more churn in the code base. All right, so that's it. I'm 8 minutes early. I went through this much faster than I thought I'd go. So yeah, I don't know. Any questions? Thank you.
How difficult would it be to, say, add output for other languages, like, say, Go or other such?
Well, so Luke did, in just a couple of months, he did it for Swift. He just took the JSON approach. So he took the JSON that Heimdal's compiler outputs as an option, and he used that to drive code gen for Swift. And he got the same sort of behavior that we have in Heimdal. So you can actually decode an entire certificate in one step, right? Totally you can do this for any other language. Thank you for asking about Go. You know, I've looked at Rust, for example, right, with Surda and stuff. And people, I mean, the approach is you have to hand transpile an ASN.1 module to Rust with annotations, and then you get everything working out correctly, hopefully. That's a lot of work still. It's manual work. I really think that whatever language you're using, you should take the ASN.1 module that comes from an RFC or from an ITUT specification or whatever, and just compile it. It should just work. Right? That's how it should work. You should not have to modify the ASN.1 modules substantially, preferably not at all. That's my preference. I hope other people take that and take it into their other language ecosystems, that sentiment, and run with it, because I don't really like seeing Rust code that's hand transpiled ASN.1 modules. It gives me the heebie-jeebies. Yeah. And the same thing applies to Go. Yeah.
Sure. Nico, do you think there's any chance that if we make compilers more ubiquitous, that the ASN.1 haters will back off a little? Yeah, that's a great question. So this is where I can show myself as a protocol buffers hater. Right, so the history of ASN.1 is that in 1984 it looked a lot like protocol buffers, right? Except that the tags were optional. I mean, protocol buffers, you always have to write the tags, and it's really annoying. And they had similar ideas about extensibility. Well, you're just going to append new fields in the future, and it's going to work because old versions are going to, old codecs are going to ignore the new fields, and so on. And after a decade or two of experience, this turned out to be unsatisfying. And so ASN.1 has evolved a great deal in the last 35 years. Right? And they have a lot of experience. It's basically a type system. It's not just an IDL. It's a rich type system that lets you do a lot of things in a very formal way that almost nothing else out there does. And formalisms are the things that unlock this one-shot codec that Heimdal has that nothing else to my knowledge, in the open source world has. So, yeah, there's a lot of value in the formalisms. Now, ASN.1 wasn't free back then, and there was all this cargo culted ASN.1 handbook kind of stuff that had lots of errors, and so people hand-coded everything. But if you look at XDR and what Sun did in 1986 for NFS, they built themselves a compiler for a slightly smaller language than ASN.1, and it wasn't hard. There was no reason that people couldn't do the same for ASN.1 in 1988, but they didn't. I don't know why. And then along comes Google and actually everybody else, right? So if you go to the Wikipedia page for serialization protocols, there are many serialization formats, like lots. I don't remember how many it was, but I should have counted it before this talk, but I don't know. It was like 100 or something. And there are many more that are still not listed on there. And so people come along and they go, wow, ASN.1 is a little bit ugly, and it does look a little bit like, it's yelling at me, and SQL style, right? And it's got these parsing difficulties, and I don't know, man. It's ancient, and so I'm gonna design a new thing for which there's also no tooling, right? Because the first complaint is what's ugly, but the second complaint is I can't even find tooling for it. So I know what I'm gonna do. I'm gonna invent a new thing for which there's also no tooling, and now I'm also gonna write that tooling. So I created two new things where none existed because there wasn't tooling for this one. I think that's not really very wise. People tend to reinvent the same mistakes. So protocol buffers, for example, is a tag length value encoding. But ASN.1 left that behind long ago. You can do much more efficient encoding without tag length value. OER is very efficient. XDR is fairly efficient. None of those tags appear there, right? So, yeah, you don't want to make the same mistakes. And plus, protocol buffers requires you to write the tags, even if you were going to then use flat buffers where you don't have tags. Why? Even ASN.1 left that behind long ago. They have automatic tagging now. You can say, hey, this module is automatically tagged. I don't want to ever write a tag number anywhere by hand, right? So, stop repeating the mistakes of the past. The ITU2 specs for ASN.1 are beautiful. They are better than any internet RFC I've ever seen. I've written 19 RFCs myself, and many more internet drafts. The difference between ITU-T and the IETF is the ITU-T, they have serious document writers that they pay, and that's why their specifications are typically not free, because they're expensive to produce. And like I said, they're beautiful. You don't need a book. I have a bunch of books on ASN.1 in my bookcase. I don't use them. I use the specs. They're very readable, very approachable, very easy to use. So there's no excuse not to have ASN.1 tooling for whatever language you like. And yeah, that's my thesis.
Any other questions?
All right.
Okay, please thank Nico.
Thank you.
Okay.